Welcome everyone. Myself Professor D.S. Mondhe, working as Assistant Professor in the Department of Processing and Food Engineering, Kekewa College of Agricultural Engineering and Technology. In this video lecture, I will discuss about the topic milk and milk constituents. So this is one of the lectures from the course Dairy and Food Engineering, having course number PFE 355 and course credit 3, that is 2 plus 1 from semester 5th. So starting with the introduction, milk is a unique substance in that it is both consumed as fluid milk with minimal processing, and it is the raw material used to manufacture a wide variety of products like curd, then paneer, srikhand, lassi, and many more, ghee, butter. So from the nutrition point of view, milk is an almost food and considered to be perfect food. The human body needs more than 30 distinct materials in its food supply. No, it is interesting to know that no single foodstuff supplies them, but milk supplies nearly all. Since milk by its nature perishable and an ideal product for bacterial growth, so it must be carefully handled both during production and while processing. So now milk and its constituents. So starting with the definition, that is what is milk. The Webster's dictionary defines milk as a white or yellowish liquid consisting of small fat globules suspended in a solution secreted by the mammary glands for the nutrition of the newborn. So milk is a very complex food with over 10 raised to 6 molecular components. The principal composition of milk, as shown in the next slide, including fat, protein, in bracket that is primarily casein, milk, sugar or lactose, and the minerals of milk are found in varying proportions in the milk of different animals. So milk constituents. So this tree diagram shows the various milk constituents. The main constituents of milk are nothing but water and total solids. The total solid contains fat and solid not fat, that is SNF. So fat. Fat is again divided into two classes, that is true fat and associated substance. The true fat is again has a classification, that is several fatty glycerides. Associated substances includes phospholipids, cholesterol, carotene, and vitamins A, D, E, K. The solid not fat again classified into four classes, that is lactose, nitrogenous substance, mineral matter, and other constituents. Nitrogen substances has again classified into two subclasses, that is non-protein and protein. Non-protein includes urea, amines, creatinine, creatine, uric acid, adenine, guanine. So protein substances include casein, that is alpha, beta and gamma, lactalbumin, that is alpha, lactoglobulin beta, and proteose peptones. The mineral matter includes phosphates, chlorides, Na, that is sodium, calcium, traces of Cu and iodine. Other constituents include pigments, dissolved gas, vitamin B complex, and enzymes and bacteria. So while going into detail, first we will start with the water. That water is the largest fraction of milk and ranges from 80 to 90% depending upon species and breed. So that is in milk near about and on average 80 to 90% water is present, and this proportion is varies depending upon species and breed. Water serves as a carrier for other constituents of milk to hold solids of the milk partly in solution and partly in suspension. So next milk constituent is milk fat. The fat in the milk exists in the form of small globules which averages approximately 2 to 5 microns. Fat is nothing but the oil in water type emulsion. So milk fat is composed of a number of glyceride esters of saturated or unsaturated fatty acids. This make up to 98 to 99% of the milk fat. The size and arrangements of the fat globules affect the creaming ability of milk, the viscosity of cream, the ease of whipping cream and churning of cream to butter. So this milk fat is a rich source of energy and a good source of vitamin A and D. The next constituent of milk is milk protein. The milk normally contains about 0.5% of nitrogen, of which 95% constitutes milk protein and 5% non-protein nitrogen. Milk protein contains all essential amino acids and particularly rich in lysine and valine. There are three principal classes of proteins of milk, that is casein, alpha lactoglobulin, sorry, alpha lactoglobulin and beta lactoglobulin. Alpha-lactoglobulin and beta-lactoglobulin are known as whey protein or serum protein. The casein is a phosphoprotein which is found in no other product than milk. So that is, casein is the only phosphoprotein that is present only in the milk. It accounts for 80% of the total protein content. The viscosity and white color of the milk are largely because of casein. So casein is responsible for the viscosity of the milk and white color of the milk. Alpha lactoglobulin about 3%, 3.5% of total nitrogen content of cow milk, and it is precipitated by heat. The milk normally contains about 0.5% of nitrogen, of which 95% constitutes milk. The next constituent of milk is milk sugar, or it is also called as lactose. So this is responsible for the sweetness of the milk. It occurs exclusively in mammalian milk. The average lactose content of cow and buffalo milk is 4.5 and 4.8% respectively. Lactose is acted upon by bacteria to produce lactic acid and other organic acids and is important in various milk products. It is important for texture and miscibility of some milk products. So enzymes. A number of enzymes present in milk. More than 25 enzymes have been identified in cow milk. The milk enzymes are of considerable importance in certain aspects of milk technology. For example, lipase is responsible for the development of rancid flavors in milk. The principal enzymes natural to milk are catalase, peroxide, xanthine, oxidase, alkaline, phosphatase, amylase, protease, lipase, and aldolase. So the next important constituent of milk is vitamins. Milk is a good source of fat soluble vitamins like vitamin A, D, E, and K, and water soluble vitamins, vitamin B. Milk is good source of vitamin A, but it is poor source of vitamin C. Milk is especially rich in riboflavin, but this vitamin is lost rapidly on exposure to light. It is also contains other B vitamins like niacin, pantothenic acid, biotin, folic acid, and vitamin B12. Minerals. The mineral is the next constituents of the milk. Milk is an important source of calcium, potassium, phosphorus, and magnesium. It also contains very small amount of iron, iodine, cobalt, nickel, fluorine, manganese, and silica. Minerals constitutes less than 1% of milk fat, and they influence the heat stability and clumping of fat globules after homogenization. Thank you. So, in this way, we have covered the topic milk and milk constituents.